All right, welcome back to trigonometry. So in this problem, we have three examples. We're going to try to change our rectangular relationships into something that looks like a polar relationship. So here we have x minus 5, okay, squared, plus y plus 6 squared is equal to 61. I'm going to turn this into something that looks polar. So first thing I'm going to do is I'm going to go ahead and square this stuff out. So I'm going to say this is x squared minus 10x plus 25. I'm just squaring out this binomial, plus y squared plus 6 plus 6 is 12y plus 36 is equal to 61. Let's go ahead and get all of the constants off to one side. So we'll subtract 25 from both sides. We'll subtract 36 from both sides. And then we have x squared minus 10x plus y squared plus 12y is equal to 0, right? And we'll see about this. So the next thing I'm going to go ahead and deal with, okay, is we're going to go ahead and we're going to recombine some terms here and figure out what's going to happen with this. Okay, get rid of all of this. There we go. All right, so we're going to say we have x squared plus y squared. We're going to go ahead and I'll do this first. We have minus equals 10x minus 12y. Now we have to remember that x is equal to r cosine theta and y is equal to r sine theta. We're going to need that substitution in a moment. We have x squared plus y squared is equal to r squared, so we're going to need that as well. Okay, so we got that going on. Okay. Let's get rid of some of this. We don't need any of this stuff sitting here. We'll get back in a minute. So we'll go ahead and do what's going on here. Okay. So clearing off all of that stuff. Sorry for that. All right. So we have our x squared plus y squared. That's r squared equals 10. What was x? It was r cosine theta minus 12y. Y is r sine theta. Now we have an r that's common in both of these functions. We have r squared is equal to r times 10 cosine theta minus 12 sine theta. The r got factored out to the top here at the beginning. We can go ahead and scratch out a squared here and scratch out one of my r's. They cancel them. R is never going to be 0. It's kind of a boring function, but r is not going to be 0. So we can say r is equal to 10 cosine theta minus 12 sine theta. And that is a circle. It's not centered at the origin, but that is a circle in polar coordinates. Okay. Let's see what we have next. We have x plus 3 squared, y minus 4 squared. So we have x plus 3 squared plus y minus 4 squared, and I believe is equal to 25. Let's double check. Indeed it is. All right. So let's go ahead and multiply these guys out. So we have x squared plus 6x plus 9 plus y squared minus 8y plus 16 is equal to 25. Same idea as the last one. We're going to subtract off 9. We're going to subtract off 16. Okay. 16 and 9 do in fact make 25, so that's kind of easy. We have x squared plus 6x plus y squared minus 8y is equal to 0. So we're going to do the same sort of shuffling thing we just did. So we say this is x squared plus y squared equals negative 6x plus 8y. Remembering that x is equal to r cosine theta, y is equal to r sine theta, and r squared is equal to x squared plus y squared. Let's go ahead and substitute. So we have an r squared equals to negative 6r cosine theta, and we have a y here, so plus 8r sine theta, and we're going to see what happens here. So we have r negative 6 cosine theta plus 8 sine theta. One of the r's is going to cancel. So r can't be 0. Okay, so we're going to have r is equal to negative 6 cosine theta plus 8 sine theta. And since we don't really have x or y and it doesn't really matter, we can also, in order to keep from losing our negative sign, we can say this is r is equal to 8 sine theta minus 6 cosine theta. And that again is a circle in polar coordinates. Okay, last one, it's a very similar problem. So we could say, okay, we have, what are we looking at here? We have all the way up here at C, x minus 2 squared plus y plus 1 squared. So here we go. We have x minus 2 squared plus y plus 1 squared is equal to, I believe, 5. Let's go ahead and double check. Yep, yep, we're all set. Same idea. We're going to multiply these guys out. So we have x squared minus 4x plus 4 plus y squared plus 2y plus 1 is equal to 5. We'll subtract 4 from both sides. We'll subtract 1 from both sides. It's almost as if this problem were made for you. So here we have x squared minus 4x plus y squared plus 2y is equal to 0. Let's go ahead and recombine some terms here. So we have x squared plus y squared is equal to 4x minus 2y. Okay? And again, we're going to say that x is equal to r cosine theta, y is equal to r sine theta. We can go ahead and deal with that way. Remember that x squared plus y squared was equal to r squared, right? So here we go. We have r squared, that's my x squared plus y squared, is equal to 4. What was x? It was r cosine theta, and then minus 2y r sine theta. Notice that both of these terms have an r in it. We're going to pull that out. So we have r squared equals 4 cosine theta minus 2 sine theta. We'll put the r on the outside here. We'll cancel an r on both sides. So we're going to say r is equal to 4 cosine theta minus 2 sine theta. And that's what I want you to look at for that one. All right. So that's how you convert those kinds of problems from rectangular coordinates to polar coordinates. There's lots of other different kinds of things to deal with this. Practice, but at the end, you're going to have to remember that r is equal to x, or r squared is equal to x squared plus y squared. X is equal to r cosine theta, y is equal to r sine theta. And that's like the key to unlock everything that we want to deal with these kinds of problems. All right. Thank you very much for watching the video, and I will see you in the next one. Take care.